Okay, so welcome to this last lecture of the third module, which also happens to be the last lecture for this short term course that we have developed as part of this project, which is funded by NDC Transport Initiative for Asia and supported by Federal Ministry of Economic Affairs and Climate Action, Government of Germany, and International Climate Initiative, and which is given project to IIT Kharagpur. So, we are this is we have talked about various aspects of how to do decarbonization of the transport sector, particularly focused in India and also in terms of in general. So, in this last lecture we will be looking at how to what is some of the environmental perspective associated with alternative fuels as well as vehicle scrappage policy. So, let us get started. So, in terms of when we talk about environmental perspective, again just a reminder of these emissions, the scope 1, 2 and 3 emissions, which has been explained in the previous video if you want to go and learn more about that. But this is just to recap that when we are talking about environmental perspective, what we are mostly focused on is looking at the emissions coming at different stages of the production, scope 1, scope 2 and scope 3. So, now in terms of where to for this to get this environmental angle in terms of different alternative fuels, when we are trying to compare alternative fuels, like how to get started. So, one of the from an environmental point of view, alternative fuels, what is the goal here? The goal here is to reduce the carbon footprint. The goal is to reduce the like total carbon footprint of the transport sector. So, we can move from fossil fuel to non-fossil fuel. There are variety of non-fossil fuels out there, which one to choose, which will have a lesser carbon footprint in association with how good availability of that. So, how much that fuel is available, and then also looking at its long term performance of the vehicle, long term maintenance of the vehicle using this alternative fuel as opposed to the fuel that we are using right now. So, we did, if you remember, in the second module when we are talking about this GREET model, which is thanks to the GREET team who has has been helping us as part of this particular project as well. So, where to start? Where to start in terms of getting when say if I have to make a decision in terms of alternative fuels, moving away from fossil fuel and go for some alternatives. So, which fuel to choose? So, we look at from a our target perspective, like what is the achievable strategies, what we can achieve, how to go there, and pavements we talked about in the previous video, that sustainable pavements to reduce the carbon footprint of the making of the pavements too, as attitude and behavior of the public, alternative, looking at the alternative fuels, infrastructure that has to be developed for alternative fuels. Then of course, we have to collaborate, we have to make evidence based policy. So, if you remember from the GREET discussion that we had, from fuel cycle looking from well to wheels, that is called fuel cycle. You start from the crude raw fossil fuel all the way to the wheels, like wheels means I am driving my vehicle. So, and then that is one series, like from the well you are getting this refined, goes through further refining and all that comes to the pump, and from the pump it goes to the wheels of the vehicle. Then now the vehicle has also gets manufactured. This is the vehicle cycle, which is the GREET 2 series. You got the raw materials, manufacture the vehicle, get the vehicle shipped, and the vehicle is, so when the vehicle is ready, so it of course vehicle itself had some carbon footprint because of the making of the vehicle and then all the raw material that goes into making of the vehicle. But at the same time, on the daily basis, the fuel that you are going to use to run that vehicle, that also has a carbon footprint. So, it is kind of bringing both together. So, from well to pump, and also from vehicle cycle, then pump to like basically, and then when the vehicle is not used anymore, the recycle of the vehicle. So, everything has to be looked into, have a holistic approach. That is what the GREET model also is trying to make it happen. And so, in terms of how we will do it. So, as you can look at here, in of course, there are institutions, different institutions, research centers, they have to work on the different aspects in terms of carbon footprint reduction, and then government is there, institute is there, industry is there. So, all these three has to kind of come together and create an environment where we have we can have a knowledge sharing, we can have some innovations, have R&D to reduce that and get the citizen, we bring the benefits to the citizens in terms of citizens has to participate, isn't it? This is who will participate, different institutions has to participate, government has to participate, industry has to participate, and a lot of R&D is required, knowledge sharing is required, capacity building is required to really achieve the lower carbon footprint. So, in terms of fuel life cycle emissions, again well to wake, well to stuff like extraction, transport, refining, we already had a look at it earlier, and then field to tank here, land use for the in terms of your biofuels and all that, you have the land use change, cultivation, you transport, conversion, and again transportation, then distribution. So, that is for your biofuel part. So, natural gas can also be used as a transportation fuel, but you have to you have to produce that or natural gas or as part of oil and gas production, then transportation, if you crude oil refinery, diesel, gasoline transportation, fuel pumps, vehicle operation. So, here from pump to wheel, well to pump. So, life cycle is well to wheel, from well all the way to wheel. When you take well to pump plus pump to wheel together, then you get basically well to wheel, which is energy and environmental aspect of natural gas as a transportation fuel, as along with other fuels, you can have a comparisons with the other fuels out there too. So, in terms of production, manufacturing, life cycle of a biofuel, if you look at how to make different types of biofuel. So, this is just an example which we are looking at in terms of life cycle inventory and life cycle impact assessment and the outcome in terms, again as you can see on the top box, goal, scope, system boundary, bioculture practice, conventional culture, then we try to compare those two in terms of impact assessment. So, production, processing plant, market, all those, this work was done by Pradeep Ramesh as part of his master's thesis while working with us on that. So, this is one of the kind of just an example of how you can go about doing this biofuel related biofuel or bio-based like LCA. So, here his functional unit of the system was 1 ton of processed shrimp. So, it is a feed mill, raw material transport, then transport your feedstock, hatchery transport, biofloc farm, again processing plant, and then from there there is a lot of waste emissions coming out, energy, other material going in. So, based on that you can come up with your the way you can design your LCA. So, how you will do about getting the data collection? Again, you have to visit the plant, farm as well as the processing plant, collects all those data. This is all collection of the primary data. This is just an example just to show how a bio-based LCA, if you have to do, you can do it. This is, we are not directly, and this is just to illustrate the LCA method of how to get this done. Then you have the life cycle impact assessment results, where you look at all these different impact categories from carcinogen all the way to mineral extraction. And as you can see, there are 4 major components here: hatchery, farming, processing plants, and transport. So, you see that the processing plant, which is the orange color, then yellow is your transport, then farming is your lighter green, and hatchery is the darker green. And then you see that all the 4 has impact. For most part, we see that farming has a major impact, but the other components also does so quite a bit of impact there as well. Next example is when you are talking about national like a biodiesel as a fuel. This is when you are talking about biodiesel. So, you start from the feedstock preparation, feedstock processing, biodiesel production, biodiesel post treatment and blending, then distribution and use. So, as part of this you have you are looking at there is transesterification process, you have the vegetable oils, acid and catalyst, that it gets separated out in terms of glycerol and biodiesel, it gets purified further, and then this could becomes your as your system boundary for looking at LCA aspect of it. So, If you look at the in terms of the demand for different fuels, of course, we see that diesel demand is much higher, and diesel consumption is mostly in the transport sector. 87% of the diesel gets consumed in the transport sector, 13% is non-transport. Among transport, you see that low and high commercial vehicles, light and high like heavy commercial vehicles, that is nearly 64%. Then we have buses for agricultural activity, power generation, industry, mobile towers, and others, commercial taxis. Private cars also has a pretty big chunk, around 14.2%. Three-wheelers, the private cars, which gradually will go down because we are not moving away from diesel for private cars. In the newer cars are not available in their diesel variation. So, but this is so we do use quite a bit of diesel out there. So, there is a need for why this slide, just to highlight that there is a need for replacement of diesel has a high carbon footprint. So, if we can replace this diesel with something like a biodiesel as a fuel, that will be really kind of helpful. So, we had a chance of working on a project. This is Sanjukta Banerjee. We had a collaborations with biotech department here at IIT Kharagpur, where we looked at life cycle assessment of the microalgal biorefinery. So, this work was done a couple of years ago. So, here like in some of the general stuff, like the need of the hour is the development of renewables and sustainable fuel reserves in terms of biofuel. We need energy. Energy is a global currency. We need the energy. We are using a lot of anthropogenic activity. We are using lots of fossil fuel. We will have higher population. We need the energy is required. Waste is of course a big problem. Fossil fuel, there is a depletion is there. Fossil fuel is also creating a lot of environmental issues. So, with that this work was done in terms of looking at biofuel. When you look at the biofuel production, there are different generations like first generation, second generation, third generation, and fourth generation. You can refer to the if you look at the intensive course, the second intensive course, which is the videos from those intensive courses also available on the same website. There was presentation done by Professor R.K. Sen of IIT Kharagpur and also madam from IOCL, and they kind of had a more detailed discussions of different types of biofuel and what is the status out there. But just to kind of recap here. So, it is a in terms of first generation and second generation, they are kind of first generation was well established, but high production efficiency, but there is a food versus fuel debate. So, seasonal and long growth period. So, you are using food to produce fuel. So, that leads to more higher prices for the food. So, second generation says no food versus fuel debate. Where you are looking at the food and agricultural waste. So, that also is high production efficiency, but huge pre-treatment cost is there in terms of that. Third generation, they say it's a less land and water footprint, there is carbon dioxide sequestration you can also do in terms of algae and all that. So, low biomass and metabolite production, high harvesting cost, and then you genetically modified microorganisms, that is also people are looking at in terms of to have for the biofuel production. So, the demerits of first and second generation feedstock actually paved the way for utilizing microbial biomass, which is the third one as a feedstock for biofuel production. So, why macroalgae? Because high photosynthetic efficiency with superior CO2 fixation rate can be cultivated in wastewater, brackish water and non-arable land, absence of lignin, less rigorous pre-treatment, biofuel production under the biorefinery approach, economic advantage is there. So, as you can see over here, you have the CO2 and all that H2O, your algae is produced, so microbial fuel, you have you got the algae, you can use biopigments and biopharma products, and microbial fuel cells for electricity generation could be done. You can produce biofuel production, biodiesel, ethanol, biohydrogen, biobutanol, and can be used as a protein supplement as well. Then residual biomass, which can be anaerobic digested to produce biomethane, or it could become feed as well. So, in this aim of this LCA was done, as you can see over here, was to understand and calculate the impact as well as the significance of microalgal cultivation, harvesting and biofuel production cycle on the environment by analyzing the midpoint and the endpoint category. So, what you see on top here is the product of 1 kg of algal biomass was considered the functional unit. We have already explained what is goal and scope functional unit. So, I will not go do those details again in this video, and but on top here you can see the process flow diagram from the microbial cultivation, then in situ electroflocculation, drying, pigment extraction, lipid extraction, saccharification, fermentation, distillation, and then your finally anaerobic digestion of the residual matter. And in between, you as part of the product, you are looking at different products in terms of biodiesel, bioethanol, biomethane, and then all these inputs which is you are looking at from the top. So a lot of in like a material energy getting into the system, as well as products coming out. So we can look at in terms of its how much is the carbon footprint of this process. So LCA was done again using that SEMA Pro software, which we have been using for last 12-13 years now, and it's around 12 years now. And it's again this is not the only software. You can use any software that you have access to. And then here in terms of life cycle impact, different for the biomethane production, ethanol, biodiesel, pigment extraction. So you can see the climate change impact, resources impact per kg CO2 equivalent, as well as resources impact as well. So for the different processes, life cycle impact assessment. Input electricity is the major contributor of an environmental footprint. The Indian grid mix is still thermal power from coal, gas and diesel really was 63%, and this work was done in 2022, and based on the data taken was the India Energy Outlook data of 2021. So today the number may be different. So in the future the number again will be different. So you need to always look at what is the current energy mix when you are working on any LCA work. And then we can also look at how with the current energy mix the results may change. So we can compare that with in terms of life cycle. It can be reduced by considering renewable energy sources. So we looked at how is Norway, China, Brazil, and India. As you can the comparison that you are seeing here in the graph. Of course, Norway is much less as opposed to what we see in the Indian context, but the reason for that is they are mostly more of renewable energy. So if we consider renewable energy sources in the energy grid, making microalgal biorefinery a sustainable process for biofuel and biometabolite production. So how this contributes to the policy making, like we can identify the challenges. For example, if you want to go more right now the focus is on if you go for more of this microalgal production along, but at the same time we keep on using fossil fuels as a source of energy which is used to produce microalgal based biodiesel and all. That doesn't really make sense, isn't it? We have to work on reducing the reliance of on our fossil fuel. So that's very, very important. So challenges is of course in terms of policy, how it needs certain policy in terms of what for a feedstock need to be how the local support for optimum production, role of manufacturers will be what, role of government and other organization, setting attainable goal, and also development of fuel quality standards. So for all these I would we always advocate that policy should always be evidence based and science based policy, which unfortunately does not happen in most of the countries. So biodiesel blending to achieve national targets, how much biodiesel blending, regulating pricing mechanism and ensure its cost competitiveness, provide buyback guarantees to biodiesel, mandate public sector vehicles to use blended diesel, exemptions from custom duties, income tax. So those are the ones could be done in terms of the policy part. So in terms of utilization phase, when we talk about utilization of this different aspect, there is always a question that we are going so much on the say in terms of alternative fuel. Electric vehicle is kind of picking up really well, but when we are working on electric vehicle, unless we really work very hard on our renewable energy sector and try to reduce our dependence on fossil fuel, if you don't do that, what will happen is what is being shown in this particular diagram, which is we are just moving these emissions from the road to this coal based thermal power plant in the background. So of course cities maybe get ambient air quality in the cities will get better, but overall emissions may not get down that much. Remember, electric vehicle also requires batteries, and those batteries requires a lot of rare earth and other metals to be made. So all those stuff that goes into making the batteries has to be mined, has to be processed. So that also is a cost. And of course we have the engines. In traditional vehicle components also have an environmental footprint, but this electric vehicle also the battery component, if the battery waste is not managed properly, so that itself could be a big concern and higher environmental footprint. So, all those things has to be taken into consideration when you are looking at any particular policy. So, electric vehicle, we had a chance to look at electric vehicle also, where not the electric car, because nobody will give me electric car today to dismantle it all around, but we had a had some of these like we could take apart some of these electric vehicle and looked at the internal combustion vehicle versus electric vehicle, and the functional unit was the vehicle mileage. And here you can see that internal combustion is the red part, and the electric vehicle is the green part. So, for most of the impact categories, ecosystem quality, climate change and resources, electric vehicle was lower, but on the human health aspect, again electric vehicle, because of the charging of the vehicle, of using all those coal based thermal power plant and all the emissions associated with coal based thermal power plant, it was kind of showing more impact as opposed to internal combustion engine ones. So, we set up again this was all set it up on life cycle software. This was part of the Viswa Teja's master's thesis. It was done again in 2018. So, almost 7 years ago now, 6 years ago now, and so you need to kind of look at now the newer data will be kind of different there as well. So, IC engine versus EV batteries. So, he also looked at the previous one was combustion vehicle versus electric vehicle, and then here IC engine versus EV batteries was also he studied that, and we can see that for IC engine production. So, in two of the categories, climate change and resources, IC engine production has a higher carbon footprint. And if you look at the EV batteries for human health and ecosystem quality, actually EV batteries has a higher eco footprint. So, we have to look at all these aspects, and then again as I said, it has to be more on science based policy. So, EV battery, you can look at the different impact categories. So, this PDF will be available to you, the slide set. So, you can also have a look. So, here you can, as you can see, different processes, different materials. So, you can identify certain hotspots, and you can go and look at which one to be reduced. We can work on sensitivity analysis as well. So, if you can reduce the coal mix and you increase the hydropower and go more towards Norway rather than from India, and as you can see over here, your things of course gets better, your emissions kind of goes down. So, here the EV electric vehicle electricity mix, this the green one is your Norway one, and with different electricity mix. And as you can see, as you can go towards more and more renewable, more and more hydropower, you are becoming more environmental friendly. So, which is kind of makes sense. So, that was one. So, we have looked at in terms of vehicle manufacturing part. We are kind of looking at the vehicle usage part. Then we will also look at the when the vehicle gets its end of life of this vehicle. So, this work was also done by one of our students in our lab, where we look at Maharshi. He did the work where we to look at the life cycle assessment of the street sweeping systems. So, how the street sweeping, the dust that is generated from the street sweeping, either the manual or the automated the vehicle that is being used, what is the life cycle assessment of that part. So, we had the compare inventory, utilities as like energy, material, water, equipment and packaging, cleaning, waste emissions, that is the manual. Similarly, for mechanical sweeping, and we try to compare them. So, particulate matter in terms of manual, mechanical, what is the difference, where we are different locations on campus. We collected these data, and then we looked at life cycle impact results in terms of the mechanical sweeping and the manual sweeping. So, this is the total values coming out, the human health, ecosystem quality, climate change and all that. So, that is kind of different aspect of those. Then in end of life, now talking about the scrappage, as you know that this particular video we kind of one of the aspect which we wanted to highlight is what will happen to the vehicle after its life. So, we talked about vehicle manufacturing, vehicle use, and also had a anecdotal just a small mention of how this like a vehicle, while the vehicle being used for with the example of this street sweeping example, what is the carbon footprint of the operational of the vehicle. Now, we will look at once the vehicle is out of service. So, what is the scrappage policy needs to happen. So, we have, if you look at the registered vehicle in India, it is kind of going up. total registered vehicle is going up. We see a good increase in two-wheelers is actually picking up very fast, and then of course four-wheelers are also doing that, but two-wheelers is increasing like anything. So, it's a lot of sales of two-wheelers, and they are coming into the roads for movement. So, this is from Ministry of Highway Transport. Projected numbers of end of life vehicles, since the government has come up with certain policies now in terms of what is the number of years a vehicle will be allowed to run on the road. So, we will see a kind of after a certain time these vehicles will come out, and they will become part of end of life, and by 2030 we are looking at almost 2.8 million vehicles. So, this up to the blue line, which goes the real data, which was around 2017-18. So, and then from after that we are right now in 2024. So, we are close to around 2.5 million vehicles, but by nearly 3 million vehicles by say above after 2030. So, lots of vehicles. So, what to do with this, and what to do with that in terms of the scrappage. So, what is in there? So, this was a study done by Terry, which I will share that study with you as well. So, around 69% is steel, 4% rubber, 1% copper, 1% some other material, 16% aluminum, 5% plastics, and so this is there. And but it is not keeps on changing. So, since this information is from 2017, today is 2024, many of these numbers may have changed. Today we are seeing more and more plastics and plastic based material being used in the vehicles, less steel being used in the vehicle, which is again helped the vehicle to have a better fuel efficiency, better mileage, because as the car gets lighter, it becomes better mileage there as well. So, that's of course that's every since the vehicles are keeping on changing. So, our this percentages will also keep on changing. But as of in terms, if you look at where the vehicle, there are places where the vehicle is being as the informal scrapping units are there. Mumbai, lower Chaul market in Mumbai, we have in Thrissur, in Chennai, we have in Kolkata, a couple of them in Jamshedpur, then Meerut, and all those places. So, that is where the these passengers vehicles are being, the informal scrapping is there. So, central policies and green tax is there in the Indian scenario. So, we had the automotive industry standard in 2015, then there was a guideline for environmentally sound facilities for handling recycling of end of life vehicles. Then we had the voluntary vehicle fleet modernization program, where then central motor vehicles amendment was there also. So, different states have also come up with some green tax in Indian scenarios, where they are asking for green for the emission based on your emissions, there will be certain taxes you need to pay. So, how people like you and me can contribute to this policy making? Current infrastructural facilities and financial mechanism would not be able to trigger a large scale scrappage. We will current infrastructure facilities, financial would not be again for end of life vehicles. Viability of original equipment manufacturers to set up end of life vehicles, scrappage units, uses and disposal of hazardous material. So, evidence based, we need to look at in terms of inspection, maintenance, regulatory environment, improve customer awareness, resolutions of related to end of life vehicle, recycling of material, providing subsidies, providing some green tax. So, again if you look at all these different policies, different stakeholders like different government agencies, institutions, research centers, industries, knowledge partners has to come together to do a lot of capacity building in this sector as well. So, very quickly I will also show you the let's get out of this PowerPoint, and I will show you this vehicle policy that I have been talking about, vehicle scrappage policy. So, this is the vehicle scrappage policy in India. So, this document has been made by Terry, available on the Terry's website, and just done last year 2023. And here as you can go through this document. We'll provide you this document. This document again, it is only we can only use it for non-commercial purposes. So, it's just for your usage for the educational and other purposes. You cannot use this material for any commercial use. So, here they talks about resource efficiency for end of life vehicles, like EPRs now has come up, disposable process, central government policies, state wise policies, global practices on vehicle scrappage is there, challenges for scrappage policy in India, what is the role of central government, role of state governments, role of OEMs and other, then conclusions and references. Not too much, it is a relatively smaller document of only of 16 pages. So, not which kind of you saw some of these information already in that slide that I just used. So, some of the information actually came from this slide, where you are in for as towards the end of the PowerPoint that you just had a look. So, for example, feedback loop for EPR, there you have your raw material, manufacture, sale of vehicle, on road, collection of end of life vehicle, dismantling, disposal, and then try to bring it back into the raw material back in there. So, those are there. So, in terms of common process followed by end of life, we look at deregistration, depollution, because removal of handling of hazardous material, dismantling of the vehicle, shredding of the vehicle, and then try to recycle. And you see that different stakeholders, Central Pollution Control Board, workers, recyclers, recycling facilities for this end of life vehicle. So, and then policy landscape, central government policies, we looked at this diagram a little while ago. Then there are state level policies as well, for different states have come up with different policies in terms of what needs to be done, and there are some global practices were also reviewed as part of this document, which you can have a look at there too. Then some challenges in terms of an Indian context, what we can do, what are the way forward for different aspects, and that's, I think that's pretty much it, and then the conclusion from there. So, this document will also be available to you. So, you can refer to this document. Again, this is not for commercial use, this is just for for your knowledge purposes. So, thank you, and thank you very much for like going through this course material. So, with this it brings us to the end of our course for this short term course that we have as part of that we have developed as part of this particular project. So, I hope it was useful to you, and if you have any feedback or anything, you can always get back to us, and we look forward to interacting more in future. Thank you.